I'm very happy to have Michal Pleban with us today. I hope I'm saying your name correctly. It's Michal Pleban, right?
Yes, more or less.
More or less. Okay, that's good. Michal and I, we first met in, I don't know,
2018, I think, in person.
In where? In prison? No.
In person.
In person. Okay. I understood in prison.
No, not yet.
Actually, it was close to Stuttgart at the classic computing, and Michal Pleban is one of the very few real specialists of the cbm-II computer series. Most of you probably don't even know the cbm-II line. That's the computer line that Commodore developed to replace the Commodore PET. And they were a commercial failure. So not many of these systems had been sold at the time, and even less of these systems are still available. And Michal has specialized on the 8088 card, processor card, that Commodore started to develop. That was one of those many projects that were never finished at Commodore, really. And so we're going to see how to run Microsoft MS-DOS on a Commodore computer. And that is it a, I think it is some kind of premiere today, isn't it? It's the first time you're actually showing this. So
well, I was showing that, I think 2 weeks ago at the
yes, that's right.
Users Europe meeting.
Yeah.
But so otherwise, no.
It's the second time.
So it's the second time, yes.
The session was pre-recorded by Michal because we didn't know how well his internet connection would be in Sealand. So I'll just play the video now, and I hope you can see my screen now. And once I'm finished, then Michal is here to answer all your questions. Okay?
Yep.
So let's go.
My name is Michal Pleban, and I would like
to you hear anything?
Yes.
Okay, so I don't have to click any more stuff. Okay.
Oh, you added subtitles. Wow.
Commodore computer. Some of you may recognize it as the cbm-II, the business computer that Commodore introduced in 1982 as a successor to the Commodore PET. It has several improvements over the PET, for example, 2 MHz system clock and 256 kilobytes of memory, which is quite a lot for a 6502 system. It has even a C chip, which will come handy just in a few minutes.
Sorry, I just...
Unfortunately for Commodore, a few months earlier, IBM introduced the PC, a 16-bit system which ran MS-DOS. And for a while, everybody thought that MS-DOS is going to become the new standard in business computing, just like CP/M was before. And like CP/M, you could adapt MS-DOS to your specific hardware architecture just by replacing the I/O functions. In this way, a lot of different MS-DOS compatible computers appeared on the market, just like the Digital Equipment Rainbow or Victor 9000, which was designed by Chuck Cabot. So Commodore wanted to join this market too, and that's what they came up with. This is an Intel 8088 processor card for the cbm-II. With it, you can create a dual processor system, or actually even a triple processor system, because you can also install the 8087 math core processor. And those processors work together. There is an arbitration mechanism which determines which processor can access the main memory. There is a communication mechanism, so the CPUs can pass messages to each other, and the messages can be passed both ways. So you can have an application working on the Intel processor calling the 6502 to perform some kind of I/O, because only 6502 can have access to the keyboard screen or disk. But you can also have an application such as a spreadsheet working on a 6502 and calling the Intel processor to perform some calculations because it's faster. So that's quite a fascinating hardware architecture, and Commodore adapted MS-DOS 1.25 to it. So basically, you could run MS-DOS on it, but the problem is you couldn't run any applications. because the applications written for the PC usually use several distinct hardware features of the PC, such as video memory, the memory layout, the specific I/O devices, because there was no API in MS-DOS to use them. So even if it's MS-DOS compatible, but it's not PC compatible, you cannot run any software. So those computers that were not PC compatible very quickly failed in the market. Unfortunately, that's also what happened with the cbm-II. And that got me thinking, what would it require to make this very different hardware architecture PC compatible? And it turns out that you can achieve a very high degree of PC compatibility with software only, so without any kind of hardware modifications. And for that, you just need to do two things. First, to implement the PC BIOS interface, which means implementing interrupt 1.0 for screen access, interrupt 1.3 for disk access, interrupt 1.6 for keyboard access, and so on. So there's around 30 or 40 I/O functions that need to be present for the architecture to become PC compatible. That may seem a lot, but they're actually simple wrappers for the existing I/O functions that can be found in the kernel, just with the interface identical to the PC. And the second thing you need to do is to emulate the video memory, because most of the PC applications write to the video memory directly, because that's faster. So they expect the video memory to be located in a specific place in memory. So to perform the emulation, we just need to copy this memory location to the real video memory found on the 6502 side. And that can be done, for example, using a timer interrupt. And that's it. With those two things, which are a software-only solution, we can run not just MS-DOS, but a whole slew of PC applications such as Norton Commander, Turbo Pascal, VisiCalc, and so on. That's quite impressive in itself, but we can do even better. We can create virtual PC hardware, by which I mean software routines that make the architecture look like it has specific I/O peripherals, which it doesn't. And for that, we need some kind of virtualization environment. So how do we create a virtualization environment on an Intel 8088 processor? Well, it's simple. This is a virtualization environment. It works by connecting the I/O access signal and the non-maskable interrupt signal, so that every time the software tries to access some I/O ports, an interrupt is generated, and the interrupt routines performs whatever emulation is necessary to make the hardware look like it has this peripheral. So for example, we can emulate a very important part of the PC architecture, which is the PC speaker. The PC speaker uses two hardware ports, one for the frequency of the sound and one for turning it on and off. So by intercepting accesses to those two I/O ports and redirecting them to appropriate seed registers, we can make the machine to emit sound, just as if it had the PC speaker. So in less than 50 lines of code, we can create a virtual PC speaker that works just like the original one. To use all of this, I created the replica of the original 8088 processor card, because the original card never made it into a production. So if you want to use some rare hardware, the best way is just to make a replica of it. And that's it, with some nice features added. So there's 1 megabyte of memory here. There is a memory card for storage. There is a real-time clock, which is battery-backed, and so on. But in essence, it is the same hardware like the original. And you can even run the original MS-DOS 1.25 if you are so masochistic. But it can do also much more. And let's see what actually it can do. So the computer starts with Commodore Basic, just as if you would expect it to. But we can also switch it to the Intel side. Oh, there's a nice boot menu. So let's boot the computer and see what happens. Yes, it runs FreeDOS. So we can use not just some old versions of MS-DOS, but also a modern version of FreeDOS works as well. Huh. So what about Norton Commander? Does it work? Well, yes, it looks like it does. So what about this directory? Could it be Turbo Pascal maybe? Let's say Turbo Pascal works. Just give it a few seconds. Yes, Turbo Pascal works perfectly. So maybe we could program some Pascal. It's a cute little Pascal program, which looks deceptively simple, but to actually make it work, there's a lot of magic that needs to happen. To make the delay work, there needs to be timer interrupt. To make the sound work, there needs to be the virtualization support. So let's see if it works. So as you can see, we have created a PC-compatible computer basically with a software-only solution. So I hope you enjoyed this presentation. Thanks for watching it. So if you want to find out more about the Intel 88 processor card or the PC compatibility software that I wrote, just check out my website where you will find all the latest information about this project.
Okay. Thank you, Michal.
Hey.
Can I be heard again?
Yeah, thanks for playing that for me.
Sorry for the subtitles. Those were the automatically generated subtitles by YouTube. I think it works quite well, but it doesn't work perfectly well.
Yeah, it was really nice. Double Pascal was my favorite.
Okay, do you guys have any questions for Michal? Just go ahead. If you want me to help translate, then no problem. They're all a little bit shy now. They don't want to speak English. I know that.
Okay.
Are there any speed limits? Could you do something more than an 8088?
Yes. I think that the main speed limit is that you need to allow the memory to be accessible to both processors. So there are some architectural limitations with that, but we can do much faster than what this card is currently doing. What is doing now is 12 megahertz V20 processor, and I have made some preliminary designs for a 286 processor, and I think it could run possibly up to 20 megahertz. I think that should be possible. Then you run into problems with memory speed. It uses 55 nanoseconds chips, and that's the fastest you can do with through-hole packages. If you want to use faster memory, you will need to use some MS-D chips, which I'm not able to solder by myself. So it is possible. It is definitely possible, and it's something that I'm looking into. Yeah, but at some point you will hit a limit, but not yet.
Okay. Toby has asked if the card is available for sale somewhere, which is the same question that I would ask. When can I have it? I need it now.
Not yet. At the moment, I have finalized the hardware design. So what you saw on the movie is how the final card would look like. And it was important for me because if you ship some incomplete hardware to people, then yeah, if you want to correct something, that it's not possible anymore. So it's done now. I'm trying to buy chips to put on those cards. So you need some Intel support chips and so on. So I'm buying them on eBay, and they take from 4 to 8 weeks to arrive from China. And then I have to solder the cards. So if there's any good soul that can help me with soldering those, it would make them available faster. If I have to solder each card personally, then I think the realistic time scale when they would be available for purchase is in about 6 months. So not yet, but quite soon.
Are you planning for any, let's say, extension ports or expansion boards, like, I don't know, an ISA port, for example, to add a graphics card or similar hardware?
Yes. I don't know if maybe that really doesn't make much sense to try to find it on the YouTube video, but there is an extension port at one side of the card, and it contains the whole CPU bus. So basically, you could turn it into an ISA port, and I don't see any reason why it wouldn't work. I mean, I haven't tried it yet, but it should work without any problems. Because yeah, an ISA bus is basically also the CPU bus with some signals. So yes, it should be possible to make it into an ISA bus, and then you can attach most of the ISA cards that were made for the PC. I say most because there are some things that are missing that you won't have. And one thing that you can't have here in this kind of architecture is DMA. That's not possible because you have a dual processor system when the 6502 has also access to this memory, and you just can't fit DMA into it easily. So you can't attach a floppy controller, but stuff like graphic cards should definitely be possible.
That sounds great, yes. Very cool.
Somebody is asking about Doom. Yeah, if you attach some kind of graphic card, then I don't see why not. Just remember it needs to be an 8-bit graphic card. So you can attach, you would be able to attach Hercules cards, CGA cards, but I don't know if there are any VGA cards made with 8-bit interface. I couldn't find any on eBay.
One very interesting thing that I didn't know before I heard your first presentation back in 2018 or when that was at the Classic Computing was the fact that there were MS-DOS compatible computers, which are something completely different from a PC compatible computer. If I got you correctly, then it was possible to adapt MS-DOS to different types of hardware by just altering the io.sys file.
Yes.
And I think there was a second file that you needed to adapt. So that was the initial plan of Microsoft on how to adapt Microsoft MS-DOS to different hardware platforms, right?
Yes, that was the plan, and MS-DOS was not developed on the PC. It was developed on some other hardware architecture. So the original idea was to become some kind of CPM successor. CPM was the original business operating system that ran on on many different hardware architectures, and MS-DOS was kind of modeled after that. So you are correct in saying that you can change the IO.sys file, and the second file, the MS-DOS sys, stays the same, because the IO.sys contains all the IO functions that are necessary to run MS-DOS, and it has some kind of standard interface. So so you know how to if you know this interface, you can adapt it to different platforms, and that's actually what Commodore did, because they also had MS-DOS 1.25 that ran originally on this card. So there is also some kind of IO.sys there, but there must be something different as well, because you have two processors. So there had to be a third file for 6502. And it worked together with IO.sys to give access to the IO functions. But yeah, coming back to your original question, the idea at first was to make MS-DOS a popular software platform. Mm-hmm. And there were many different hardware platforms that run MS-DOS. Mm-hmm. And it took most of those people quite some time to realize that running MS-DOS is not sufficient. Mm-hmm. Because you need PC compatibility. And the reason for that was that MS-DOS did not contain any functions for direct screen access, for graphics, for lots of things that were necessary to run business applications. So people who are writing stuff for the PC use the hardware directly.
So what your virtualization layer actually does is it makes the PC card, the 8088 card, IBM PC compatible. Is that correct?
Yes, that was the idea. And the idea that I had in mind was to see how far I can push this thing with software only. Mm-hmm. I think that's something that was never done before. And all those MS-DOS computers that were not PC compatible just stayed that way. And I thought, okay, so if we have this kind of hardware architecture that is not compatible, can we just use software to make it as compatible as possible? And it turns out that it's really possible. You can do lots of things just emulating the software. So that's, of course, begs the question why those guys in the 80s didn't do this kind of thing.
So at least for the Amiga, there was a software-only emulation of the PC before they brought out the sidecar.
Yes, of course, and you can do a software-only emulation of the PC on any platform. It's just the question of how slow it would be. Of course, on the Amiga, it had to emulate the 8088 processor using software. So from what I remember, it was really, really slow.
Yes, it was.
The PC transformer was extremely slow.
Yes.
Yeah. And I mean, this is you said that you're having a NEC V20 processor on your card running at 12 megahertz, right? I mean, this is way faster than any XT computer at the time was. I mean, I remember XT computers back at the time running at something like 9.54 megahertz, something like that, around 10 megahertz. That was the peak of XT computers at the time. And then, of course, the 286 took over and that was faster. But 12 megahertz NEC V20, that is quite a fast machine. That is a very fast PC compatible.
Yes, for a XT class machine, this is really fast. Of course, you need to remember that some of the processing power is used for emulation.
Of course, yes.
But still, yes, it's much faster than what you could normally buy in the 80s.
But the actual virtualization layer runs on the 6502, right?
It runs on the V20 as well.
Okay.
But if it needs to do some actual I/O, then it needs to call the 6502.
And it uses the little cable that you showed, right? The little.
So this magic cable is used to generate an interrupt when you try to access an I/O port, and this interrupt occurs on the V20. So the V20 then looks back at the code that caused the interrupt. It knows which I/O port was accessed. Are we trying to write to that port, or are we reading from this port? And then it calls some interrupt handler routine based on the port number. And that routine does whatever it needs to do to have the hardware emulated. And if it involves any kind of actual hardware, that of course needs to call the 6502 to do the stuff. But it always begins on the V20.
Okay, but that means that, let's say the cbm-II line, they're using the 6526, I think it's called video chip. No, what's the video?
No, it's Motorola 6845.
There you go. Yeah, I was mixing up the numbers now. But that video chip is actually, well, kind of similar to what was used on CGA cards and on Hercules cards, if I remember correctly. But it wouldn't be possible to emulate any of these cards using your virtualization layer because of the interrupt problem and most likely the timing, right? Or do you think it would be possible?
No. The thing with the 6845 CRT controller is that it's only a half of something that you would normally call a graphic card.
Okay.
Even Motorola called it a display address generator.
All right.
And that's all it does. You program it and it generates addresses that should be read from the video memory. But what those addresses actually mean and what is actually done with the data that is read from those addresses is completely up to the second half of the graphic.
Okay.
So on the cbm-II, it's simply a text display. And that's all that you can do, and you can't make it into anything else.
Okay.
What I'm doing here is, and it's the only thing that you can do with the cbm-II without any significant modification, is that I have a modified font chip, which contains some characters that are normally used on the PC, like backslash, which are not present in PatchSkey. That's the only thing you can do. If you want to do some other graphics, especially bitmap graphics, you need to attach some kind of external display control. Okay.
That is very interesting. Now, do you think it would be possible to, let's say, integrate something like a Hercules card and then attach that to the integrated monitor of the system? I mean, there is a monitor in there. It's a very nicely shaped case. So you wouldn't want to have anything attached to it that's standing next to it, or a second monitor or something like that, which would be quite easy as far as I understood. But would it be possible to integrate a Hercules card? Let's stick with that example because it's a monochrome card as well, and then have its display, its graphics displayed on the integrated monitor.
Yes, that should, in theory, it should be possible. Of course, you are saying about the high-profile machines, which have the
monitor. Of course, yeah, only the high-profile machines.
Then yes, because the integrated monitor is already capable of displaying the Hercules graphic resolution. So I don't see why not.
I would love to see that, Michal.
It should definitely be possible, and I am trying to think right now how to do this kind of solution. Well, there is the expansion port, and you could attach some kind of thing that emulates the Hercules as well. So that should be done, and it's yeah, it's definitely possible.
Okay.
Sounds really great.
Just to understand it correctly, you don't only created a replica of the card, but also added additional functions to it, like the 1 megabyte memory and also the SD card.
Yes.
As a hard disk emulation. Is it correct?
Yes, that's correct. Because if you want to realistically run some serious applications on that, then you need memory.
And the original card didn't have dedicated memory.
No. It only used the memory that you already have in the computer, and normally that's a maximum of 256 kilobytes. So that's not enough to run basically anything. You can start MS-DOS on it, but if you want to run, I don't know, Norton Commander or whatever, then you run out of memory. That's not enough.
Yeah.
So there is 1 megabyte of memory. So you have the 640 kilobytes and some extras. And you need some storage. So of course you could use the floppy, but the floppies are slow. At first, of course, it used the floppy only, so it took about 2 minutes to boot MS-DOS from the floppy. So yeah, the SD card is used as a hard disk emulation. And because of the V20, it has some nice I/O access instructions. It runs about 1 megabyte per second data transfers. So it's very, very fast. So as you saw, you can boot FreeDOS in a few seconds.
Very cool, yeah.
That is a very cool thing, yes, definitely. Any other questions?
Yeah, I'm trying to monitor the chat as well. So there was some question about people who want to solder that themselves. You can actually do that right now, because if you go on my website, it was in the video, but I will also put the URL right now. You can find all the Eagle files and anything that you need to make this card for yourself. So practically everything is there. So you can do it even now, and of course, yeah, it can also be sold as a kit. I don't see why not. There are some nice suggestions for graphic cards which I need to explore, which also look quite cool. Yeah,
and you only need a cbm-II for it, huh?
Yes, you just need a cbm-II. Which isn't so hard to come by. There are some machines popping on eBay from time to time. And
they're available in abundances, you know, like hundreds of them. No, they're not, because they're quite rare, but if you find one, I think it's a good purchase.
Yeah. I have
I'm not at
like
cbm-II.
10 of them or something, so...
I'm not a cbm-II expert, but as I remember, there are several models of the cbm-II line, in the cbm-II line. For which models can your card be used?
Yes, so normally we speak about the high profiles and the low profiles. So the high profile model is the one with the integrated monitor, and the low profile is the one without the monitor, so you need to attach an external one. There was also the P500, which was a kind of hybrid machine with the VIC-2 chip, the same as in Commodore 64, but this is a completely different thing. So the card will work in high profiles and low profiles. And that's also an improvement from the original card, because the original card worked only in the high profiles. This one will work in low profiles too, and these are much easier to find, I think. I see a question of about CBM retro boards. I have no idea what that is, but if I Google that, maybe I will be able to. No meaningful results on Google. So what exactly? Yeah, I think that's a pet thing. Yeah. So no, the pet is a different architecture.
Let's just try to answer that question in the chat. But the cbm-II is a newer architecture. Yes. It works quite differently from the PET. It is a lot harder to program, which is one of the reasons why the cbm-II never really was a success on the market. But it is a different architecture. So no, it will not work in the PET or on the. On the other hand, it would be a very interesting project to make a cbm-II replica board, which I think nobody has ever tried yet. But that would be quite interesting from my point of view, at least.
Yeah, there were some talks on the Facebook group about doing that. Mm-hmm. But of course, that's not as easy to do as with the PET, because the hardware is much more complicated. Mm-hmm. So it should be possible. I mean, everything is possible. They're making a Commodore 65 replica right now, so why not the cbm-II? You would just need much more chips for that. So the PET is a very simple machine. It can be done, of course.
Well, there are actually a few experts on the internet on the cbm-II line. It's not many people. I think it's like 4 or 5 people. One of them would be Steve Gray.
Yes.
He knows everything about the cbm-II line, I would imagine. Yes. Then there's Michal Pleban, yeah, right in front of you. He's one of those few experts of the cbm-II line. I think there's another German guy. What's his name?
Christian Forstreuter.
There you go. You go. Christian Forstreuter, he's a very knowledgeable guy as well. He has developed the graphics card for the cbm-II line that is actually using the same graphics chips as the MSX computers, I think. MSX or MSX2, I'm not sure about that. And then there's me, who programmed the game for the cbm-II line, which I already showed you on, I think, the last RETROpulsiv. And then, yes, that's true. There is Helmut Proxa, of course. Helmut Proxa is one of the people that I think he's responsible for the fact that cbm-IIs were sold at all on the German market, or on the worldwide market, because he developed a board, a piece of hardware extension that allows you to emulate several PET computers on one cbm-II system, which is a very interesting thing. So you buy one cbm-II computer and you can run, I think it's 4 or 5 PET computers on that system at the same time, right? I think it was 4 or 5. I don't remember.
I think it depends on how much memory you have.
Yeah, there you go. Exactly.
Each PET needs 64 kilobytes of memory. So if you have 256, then you can run 4.
That's right.
If 1 megabyte, okay, you can run 15.
Yeah. Okay.
So he is the original cbm-II expert.
That's right. He was the first one.
Yeah.
Okay. Are there any more questions to Michal? If not, then thank you very much, Michal, for your presentation and for the time you spent with us during your holiday.
Yeah, thanks for inviting me.
Sure.
It was really nice to meet you all.
You can stick with us if you like. Most likely we will be switching back to German now, because most of the people in our RETROpulsiv are speaking German, and even my English isn't that well. So, but feel free to stay, and thank you very much again for your presentation.
Okay, thanks again for having me. I hope that I will be able to meet some of you in person when all these things ends finally.
That would be so good. Yes.
Great joining you. Thank you very much.
Thank
So
you.
you have to come to Augsburg sometimes.
You definitely have to. Yes.
Yes.
Yeah, I don't see why not. I mean, I went to Stuttgart, so I can.
That would be really great.
Yeah.
We'd love to have you here in Augsburg.
Yeah, why not? Yeah, hopefully soon.
Okay. Okay, so thank you.
Hey, thanks again.